Welcome to Interdisciplinary Invention Challenges, pivoting from hands-on to digital. I just wanted to give a brief overview of our session today. You can use the chat box to continue your conversations and engage with each other, and also to introduce yourselves to each other. You can also use the Q&A box that'll be available to ask questions of the panelists, and we'll go through those as the presentation goes along. This program does have live captioning. Click on the closed caption button on the bottom of your screen to access the captioning, and this program is being recorded. So welcome. My name is Tim Pula, and let's get all of our panelists up on the screen here, and we'll do some introductions. All right, so I'm Tim Pula. I'm the interpretive exhibits inventor for Sparklab at the Smithsonian's National Museum of American History. I get to create a lot of hands-on activities for a hands-on invention space. And today we're going to talk a little bit about a story of how we've transitioned that when COVID took hold. So I'm going to pass it off to Daria and let her introduce herself and let that team at Autodesk start.
Perfect. Thanks, Tim. Hi, everyone. My name is Daria Zhao. I lead marketing for our K-12 efforts, also known as youth. So that includes Tinkercad and Instructables, as well as Fusion 360 in high school. So you'll hear about some of these products today, as well as how the Sparklab team was able to use those to adapt from digital, from hands-on to digital, and come back full circle as we're approaching the end, hopefully, of the pandemic. What about you, Kellyanne?
I remembered to unmute myself. my name is Kellyanne Mahoney, and I'm a youth program specialist at Autodesk. I'm also a former public school teacher. I taught middle school for 13 years prior to joining Autodesk about 4 years ago. So I'm excited to be here and be around other educators, and excited to learn also from Tim today too. And should I pass it along to Guillermo?
Okay, hey, how are you doing? My name is Guillermo Melanzoni, and I'm Senior Program Manager for Tinkercad and Fusion 360, also the lead for Tinkercad product itself. And yeah, been working with Tim. I think it was one of my last two trips. One was Smithsonian, was the previous to last, and the last one was on a meeting in which we met in Houston. So yeah, good to be here. I need to choose somebody. I have Jenny then.
Hi, everyone. I'm Jenny Fennell, the Content Development Manager for Youth at Autodesk. And I work with this wonderful team here on a lot of different learning materials and other projects related to supporting teachers and students in 3D design and make. And I'm excited to be here, and I will be leading us through an introduction to our lesson plan overview a little bit later today. So thank you for attending. Matthew.
I am Matthew. I'm the community manager for K-12 education at Autodesk. I work a lot with Instructables and with Tinkercad and with Fusion and the teachers who are using that in their classes and with their students, and trying to figure out how to best help those teachers out and how to best provide for them.
All right, so that's an introduction to the team today. So in today's presentation, I guess we'll start off actually by telling the story of how this all came about, and we'll start with a bit of what happened and how this worked. So let me share my screen here, and we'll start with the story. And here we go. So to start with, Sparklab, for those of you who may not be familiar with it, Sparklab is a hands-on invention studio that exists at the National Museum of American History. Sparklab is kind of situated in a way that I'll kind of describe how that works. Smithsonian is made up of 19 museums, the National Zoo, 9 research centers, and our mission is the increase in diffusion of knowledge. Now, one of those museums is the National Museum of American History. We have the Star Spangled Banner, Lincoln's top hat, ruby slippers, and a lot of great objects that people come to see on their pilgrimages to the Smithsonian. We also have a vast history of technology and collections. The museum did start out at one point as the Museum of History and Technology. So that's where the invention aspect really comes in. And the Sparklab exists within the Lemelson Center, which is a center situated within the National Museum of American History. We do research, we do history, we have our own historians, we have archivists. So we are kind of our own little microcosm within the museum itself. And that is where you'll find Sparklab. We're one of the education outreach portions of the Lemelson Center. You'll also find Sparklabs across the country. So Sparklab doesn't only exist at the National Museum of American History. We have Sparklab National Network sites throughout the country. And right now, I believe we're up to about 9, I think we're at 9 right now, and we have 3 more online to come up within the next year. So we are getting ready to do hands-on invention education. You know, as we're coming out of COVID, we've got a number of sites who've been working on pushing for hands-on invention education outside of the digital realm. But today we'll talk about the digital realm and how we had to actually draw that back and move it into digital and actually create a great platform in order to enhance invention education. So as we think of invention in Sparklab, we think of it as a process. Invention is this process, and through research and interviews with current inventors and research in our archives from inventors who have since passed, we've been able to kind of distill the process down into 7 steps. Think it, explore it, sketch it, create it, try it, tweak it, and sell it, which we are also, or share it. So sell and share, a little bit the same thing. And we get that process across as people enter Sparklab. We actually give them the opportunity to engage in multiple steps of the process, or even 1 or 2 of them. Another thing with Sparklab is we really want our visitors and those who engage with us to realize that everyone is inventive. On the left-hand side, you'll see some people, when people think of inventors, they usually think of Edison or they think of Steve Jobs, but everybody's inventive. Everyone is inventive. We have Stephanie Kwolek with the invention of Kevlar here. We have Alexis Lewis, who created this treboir and has also gone on to invent a couple of other equipment pieces for safety when it comes to fires. We have multiple inventors, and as you see, there's a diverse face, a number of different faces, different backgrounds, and we even feature some of our young inventors on our walls in the Sparklab space. And then inventions all around us. That's another thing we try and convey in Sparklab, and the idea that everything that you use in your daily lives is an invention, whether it's the fabrics that are in your clothing, or the materials that your laptop is made out of, or even the electronics that are inside of your cell phone. Those are all inventions. Somebody had to come up with those ideas and lay them out and invent them and create those things. In Sparklab, you'll see when you enter Sparklab in the physical space, this is what you'd see if you came in through our front doors. You would see our object wall that's towards the back left of the room. You would see a case with that actually has like small objects in it. Right now, it has Invented Challenge winner inventions in it. So kids who have invented during the Sparklab Ingbe Yoon Invented Challenge, we've displayed their inventions in the case near the front left of the room. You'll see a bunch of tables in this space, and those are places where we allow and encourage and challenge our visitors to engage in the process of invention. And what you'll notice as we go through this presentation is the amount of materials and types of things that we put in front of visitors as they explore the process of invention. So in the object wall, some of the things that we have is we have inventor profiles. We have props that encourage people to think along a certain theme of invention. And we also have museum collection objects. So some of the objects that we have on display in this particular case on the far left, we have one of the earlier GPS units for farming. We also have models from different farming equipment. We have box apple crate graphics. So the idea of invention through selling and how to sell an object. So we're looking at invention through a number of different lenses. And with the museum's really rich collection, we want to convey that. And then with some rich props, we want to convey what invention looks like. This is what invention looks like as visitors take part in it in the Sparklab space. You'll see the image on the upper left of a girl getting a successful high wire driving invention. You'll see on the right one of the other faces of invention, which is frustration, and one of our facilitators trying to help a visitor get through some frustration on an activity that they were working on. And then down at the bottom, a very innovative designer who's created a prosthetic hand, which was one of our activities. So we try and use materials that are interesting and that are applicable to students, and they can really try new things, try to invent in ways that they hadn't before. And as kids are inventing, we try and come up with a lot of different themes, a lot of different ideas. You see here, upcycle e-waste. The bottom left corner image is inventing a green building, thinking about lead building technologies and the idea behind building a green building. In the upper center, you'll see a belt drive system. So the idea of factories and automation. We have a vending machine down there near the bottom, and we have and then we also have a video game piece as well on the right. And then here, after we go from those activities, another thing that we get people doing in Sparklab is we get them sketching, we get them drawing on chalkboards, we get them, we give them books to research stuff, we get them working with materials that are recyclables and things that are consumable, so they can utilize those in the space. And of course, we have our Invented Challenge, which is an invention challenge for kids all around the world. So that all showcases in Sparklab. Sparklab itself has around 500,000 visitors per year, including the Sparklab network sites. And our Sparklab space in DC has about 200,000 visitors a year. Our average stay time in Sparklab is around 15 minutes. And all the visitors who come into Sparklab receive a greeting. They get told what the invention theme is, and we also have facilitators that help engage people in that invention process. And Sparklab, when the pandemic struck, and Sparklab being a hands-on space, the museum closed down, Sparklab had to close down, and we had to actually shut down pretty much everything that was physical. And we began the process of trying to figure out how to turn Sparklab digital. Fortunately, we had been collaborating with the team at Autodesk before that to create some digital add-ons for the physical Sparklab space. And then the digital end was supposed to be a part of the project later on. But we kind of jumped from step 1 to step 3 pretty early on and made Sparklab become just kind of a huge digital platform. And that's what we were pushing for in that, or we're beginning to be a huge digital platform now, or laying that out. And thanks to the folks at Autodesk, that's something that's very possible and very, and it's in works in the process. So that's the story of Sparklab, the physical. And now I'm going to turn it over to the Autodesk team and let them talk a little bit about the digital side of things at Autodesk and what they have to offer.
Thanks so much, Tim. So as we just heard, there are a lot of things that Sparklab and the Smithsonian are doing to encourage the next generation of innovators and inventors and the invention process. So how does this tie to what Autodesk is doing? At the core, it's really about the fact that we can't prepare our kids for everything, but we can prepare them for anything. And so one statistic that simply blows my mind is the fact that the World Economic Forum estimates that about 3 in 5 kids who are entering elementary school today will end up working in jobs that do not yet exist. And so what does that mean for what we educate or teach our students? What do we expose them to them as they're growing up? And the answer that we found at Autodesk, as the creators of software for people who make things, so everything from green buildings to smart factories to clean cars, that's the software that Autodesk commercial customers are using. And so how do we bridge the gap between what we see in education today, which is lots of opportunity for things that are changing, with some of the commercial opportunities that we're seeing? And what we arrived at in the education side is that we need to introduce kids to the building blocks of innovation. Part of that is the invention process. Part of that are core competencies like 3D design or electronics or coding. And these are things that can be remixed, combined, or layered to create powerful new solutions. And what that means is we can't predict the jobs of the future. If we did, that would be fantastic. But what we can do is we can prepare kids with foundational skills. So Tinkercad is one of these products that we have to introduce kids to these foundational skills, and so is Instructables. These are 2 platforms that my colleague Matthew and Tim will go over to introduce how that happened exactly. But on a more high level, again, these are things that we think have been typically taught in silos, but they're converging both in industry and in the classroom, with a lot of educators who are experimenting on the forefront of what it means to teach kids and equip skills with equip them with the skills they need to succeed. And so without further ado, I would love to hand it over to Matt to provide us a quick walkthrough of what these platforms look like, as well as how Sparklab has implemented them for a lot of this work.
Absolutely. Thank you so much. I'm just going to share my screen so I can walk you all through some stuff. So I want to kind of show off Instructables and Tinkercad and kind of how they're used, what's being done, how teachers can utilize them. If you don't know, this is Instructables. It's a project sharing website. People post things. The way Sparklab and us like to think about it is kind of like an exhibit space. So you can exhibit a project you made, you can show it off in any category that you want, and you can show kind of the step-by-step sequence that you use to make it. We have different sections on here, one of which is teachers, which provides a lot of kind of helpful kind of walkthroughs for teachers on how to incorporate things into classrooms. There are teachers that are using it to kind of create collections of projects that their students make, kind of like a gallery. And then other teachers who are creating something, a project, and like I said, like, hey, if you're one of my students, there's a math assignment associated with this. And then having their students post as a, I made it at the end. So you have this collection of student projects that kind of showcase what they're all doing and provide the answers that might be needed to show off. And then Sparklab also has an awesome page where they showcase a bunch of projects on here. And you can dive into any of them and you can get this kind of step-by-step with included, like if there's Tinkercad embeds, you can kind of get in here, look at the embed, kind of click through to open it up in Tinkercad, model with it, design with it, and actually get into the nitty-gritty with it. And yeah, a lot of information. And I think that, Tim, you might want to talk about some stuff here.
Matt, if we can go down to this export section here. So as you saw from my quick presentation or quick tour of Sparklab, the physical Sparklab space, we have museum collection objects in the space as well. And one of the things that we wanted to do when we laid out a digital platform was we wanted there to be space for the museum collection. So under the export step, which in the invention process is when somebody starts thinking about what's been made before or how things have been done before, one of the things that we've done is we've included links to Smithsonian learning resources, whether it's Smithsonian's Learning Lab, which is in that top link there, which Matt will take us to, where Smithsonian staff and teachers can actually create collections of objects as well and actually tell stories, set up lesson plans. This one happens to be about the invention process viewed through the lens of the invention of the telescoping shopping cart. So we have great photos from our archives, sketches from our archives, and even images of actual collection objects in this particular learning lab. So this is one way for us to share that museum experience by putting it here in the Instructables platform. And let's go down to to this one here. So that one's great. The collection of shopping carts. So again, pieces from the collection, images of the objects that we have within our collection, and you can find information on them. So not only do students get to go through that invention process using the Instructables platform, they're also being immersed in history. So we're tying history into this as well. So it's the STEM, it's the history, it's the art side. We're trying to tie all of that together, which is all part of that invention process.
And we talked about how, is that all you wanted to say about this, or did you want to talk about any more?
I think the only other thing that I do want to mention about it is one of the reasons that we decided to use this platform, and I know that folks at Autodesk, they don't really play it up very often, but it's all free. This is free and easily and openly accessible. And that's one of the reasons we were trying to do this. As we converted to digital, one of our biggest challenges was, where do we find a platform that people don't have to pay to use, especially one that's powerful enough to allow them to engage in this type of process or engage in something that's a model of our invention process that we're sharing in our space. So being that Instructables is free and Tinkercad, which you'll hear more about later, is also a free platform, that was just a great way for us to partner and to lay that out in a way that's just as accessible, if not more accessible, than going into the free museum space that we have.
And in line with that, like I was saying, like this is sort of the exhibit space for students, for teachers, for anyone to kind of show off their projects. And in line with that, we look at Tinkercad as that activity station. So where you can tinker with model design and mess around with that project. For anyone who's not familiar with Tinkercad, there's 3 different places. You can do 3D designs, you can work on circuits, and you can work in Codeblocks, which allows you to actually do block coding to design 3D models. So it's just, you get to design in 3D with code, which is really kind of cool. With that, you have a lot of kind of options up here. You can create classes and kind of have your whole classroom in a classroom to see all of their objects. I won't take you through mine right now because it's just my son. But up here, you also have things like Learn, which has starters, lessons and projects for 3D, for circuits, and for code blocks. And they take you through inside of the application. They'll take you through the steps and the processes for building that thing. So it's kind of like inline directions to kind of take you through, okay, here's exactly what you do within the program, which is kind of nice. There's the Teach section, which has a lot of information for teachers, where to find kind of lesson plans, where to find projects, where to find helpful information. And one of the cool things that we've started doing that Jenny is going to talk about a bit more later is our lesson plans. And we have lots of lessons plans. We're constantly creating more of them. One of them, similar to the Instructable that was created, was the Reinvent the Shopping Cart by Sparklab, which has a lot of information, again, like the steps and the design and how you kind of implement that into your classroom. And that is,
Matt, can we open up
yes.
one of the Sparklab designs? Do you have one of those available to open up?
Yeah, I have any of these.
Okay, yeah, let's go ahead and open up one of the designs there real quick.
Yeah, absolutely.
So as Matt was saying, the Tinkercad platform, when we looked at that, again, that's free, open access to students. And when we were looking for something that was safe, and free and open for students, this was a great platform for us. And one of the things that we decided to do is this became our activity station. So you saw in those pictures that I shared earlier, you saw the kids with the prosthetic hands that they had built, or with with the wire driver activity, the piece that they had built. This is where we lay out a set of materials that students can use to create something along an invention challenge. So that invention challenge lives in Instructables, or now some of them live in the platform that we'll talk about a little bit later on, the lesson plan platform. But this right here is the building set. What's really nice though, and what we've really enjoyed about this, is when we had in our physical space, we can only supply so many materials for students to build with. And we were constrained by a lot of just basic physics principles of this fits together, this doesn't fit together, it's too heavy, it's too whatever. But within the 3D platform like this, those physics constraints aren't as much of a challenge. So kids are a little more able to invent more freely in this space. And the other thing that's great about it is that we have all the basic shapes and all of this huge library that Tinkercad already has in place that allows students to pull custom shapes, basic shapes, anything like that. So Matt, could you pull just something out of the Tinkercad library and drop it into the space there? So you can add anything from here into that space, and then that allows kids even more freedom to create. So you pretty much have an infinite or nearly infinite set of materials to be able to create with. And that allows our kids and our visitors and those interacting with this particular platform to really think as openly as they choose to, as creatively as they choose to, or as technically as they choose to, or just to have fun with it, which is really nice. And as kids design stuff in our physical space, we do see that sometimes things go a little awry of what we initially had planned as the idea of how you might create within the space. But in Tinkercad, that same thing is there, that same aspect is there, and they can choose to do it however they want, and it may allow kids to spark something in their head that wouldn't have sparked if they were under a more restricted type platform or under something that has more constraints to it. Being that this is so open, it really does allow for open freedom.
Yeah. Sorry, I'll stop playing. But yeah, that's all I have to say. It's hopefully if there's questions on it later, I'm happy to answer any of them.
All right.
And
So
with
now,
that,
yeah, so with that though, with that, I want to just open it up for questions real quick. I know we were kind of thinking about it a little bit later on, but we're kind of transitioning over into some more of what's available through this. So does anybody have any specific questions? I did see one in the question and answer, which I think would best be answered by Guillermo when he comes up in just a moment. So that will be a really good one. Or Guillermo, would you like to answer that question right now?
Which one are you talking about?
It's in the question and answer. It says, what is
Yeah.
the state of the art in CAD by augmented reality headset systems? Do you see that one?
It says, what is the state of the art of CAD by augmented reality headset systems such as HoloLens? Has anyone been able to use binocular AR in a museum experience?
That's a good question. Yeah, I mean, there's
Yeah.
I can answer now. I mean, unless you want it later.
Yeah, I think that would be good. Let's answer that now, because I know that you have mentioned a number of AR tools that are available, or at least one AR tool that's available through Tinkercad. So I thought.
Well, we actually have an embedded AR solution on the Tinkercad version of the iPad, right? Because that's the device that has a camera and that we know the camera well, right? So if anybody uses Tinkercad, download it from the App Store, which is again as free as normal Tinkercad. It's the same Tinkercad, it's just the delivery mechanism is different, right? So it's an app that just calls the website, but it's the format is an app, and then we can leverage the camera of the iPad, and then we can basically do AR in there. We have never gone too deeply into VR, and there's a reason for that. I mean, our core audience is younger than 13, right? And there's a lot of questioning about using VR for younger than 13 in general, right? So it doesn't seem to be a perfect fit, but AR definitely we acknowledge it and we embrace it with the one place in which we know that we have the product and a camera in the same place, right? So yeah, so that will be my approach. So if whoever asked that question, just take a look at the app on the iPad, and they can do AR. And anything else would be something that, I don't know, it will be hard for us to get into a full VR implementation, understanding also the limitations of the questionings that are around VR on early education, right? So I don't think anybody wants to have a full immersion on a kid on a headset that can get dizzy, can fall down, can hurt, all the things can happen in a classroom. So yeah, that's kind of the place where we are today. Have we done experiments of modeling in VR? Yes, we have. Are they awesome? They are, but I'm not sure they are for the right age. Right. Okay, and with that, anything else, or can I maybe start on my?
we have a second.
I will add, just chatting with teachers. I know some of them that have their students create their stuff in Tinkercad, and this past year they weren't able to have their showcases, so they weren't able to show it off in the actual schools. So they did digital showcases. Those teachers actually use stuff like Unity to take those Tinkercad projects, create something that teachers and students can kind of virtually walk around in and actually experience those things. So it is possible, but it requires some lifting on your end as well.
Yeah, exactly. I mean, nothing prevents you from getting an OBJ from Tinkercad into whatever platform of choice, Unity being almost like the first obvious choice. But then there's a whole set of other constraints on the other side about learning the platform and doing all the things that, I mean, it's not as magic as, okay, you throw it there and it whole works, right? So yeah, that's something interesting to explore. It's just also, it depends if it's VR for viewing as opposed or VR for modeling. Those are completely different scenarios too. We've tried both. It's again, it's very interesting, the things you can do. It's just a matter of how long do you want to keep a kid with a full immersion on a classroom, right? I don't know. I mean, it's right now what it sounds like, it's the answer is not much and the least possible. Okay, I'll start sharing my screen then, I guess. And I'll get started. So what I want to do is just a brief introduction of Tinkercad and some guiding principles about what we're doing, as short as I can, although I'm not known for going short, but anyways. My name, as I said, is Guillermo Melantoni, just in case. And if anybody needs to communicate with me, it's always first name dot last name at autodesk.com. So we are very easy to find. And I am the lead for Tinkercad. I'm also one of the leads for product management for Fusion 360, mostly on everything about education with Fusion 360. So when we talk about sort of the whole narrative between from Tinkercad to Fusion a little later, I mean, I kind of have my feet on both, which is actually very good, pretty convenient. Just a little bit of numbers so we all understand what we're talking about with Tinkercad. It's funny because I have to update this slide pretty much every time I make a presentation. I believe we're almost at 38 million already, so it's more than 37. It's not inaccurate, but it's a lot of people, right? So monthly actives always around the 3 point something, 4 million, depending on the month, depending if it's vacations or anything on those months. The app on the app store that I mentioned, over 3 million downloads by the beginning of the year, so it's probably more like a 4 million now. Lots of millions of models saved, and each model has all the revisions, so all the versions. So we have billions of models saved in the cloud, up to 15,000 concurrent users. So at any given point, if we look at infrastructure and our servers, there's around anywhere between 10,000 and 15,000 students working with Tinkercad at any given moment, which gives us kind of peaks of almost 500,000 users per day and 60,000 new users every day. So I always do the same analogy, but I think it's pretty powerful. Just imagine the biggest stadium wherever you live, and we feel that every day with new people, which is a lot. So a lot of things to be proud about, but also a lot of responsibility to understand how we keep that momentum and what are we really, right? So people that have started with us a long time ago might remember Tinkercad as an application for modeling for 3D printing, right? So that was the initial vision for Tinkercad, right? So 3D printers were starting to become something possible to purchase, especially by a school or a public library, right? But all the software available to make things required a level of training and abstraction for somebody already starting to study, I don't know, mechanical engineering or architecture or something like that. So there was no really good 3D modeling for the younger kids, but now they had the opportunity to build something with it without the tools. So many people were just downloading models from web somewhere and making maybe small variations, but that was it. And as we kept moving on with Tinkercad, we're also always trying to understand what are the trends, right? So we really understood that the electronics was getting younger and more ubiquitous, right? So you started to see electronic kits on the aisles of retail like Target or anywhere like that, right? So kits for building circuits. So it was starting to get into a younger audience, and also start to see that more and more in schools. right? And then programming, right? Either with Scratch or with other mechanisms. Those were three things that we really wanted to see how to put together, right? So, because at the end of the day, Tinkercad is not just something for 3D printing or 3D designing, right? It's when you think about design in particular, or a design of a thing, of a product, it involves a lot of things, and definitely making it, kind of designing it or 3D modeling it is part of it. But also if it has some electronics or any sort of behavior, does it turn a light at some point? Does it have a sensor? Does it react to certain context? All those things are very, very interesting. And many of those things also require programming. And even when you 3D model, you can 3D model by aggregation, but you can also 3D model by programming, which gives you another set of different objects you can do. So all of that put together, I think that when you get the intersection of those three things is when ideas can just blow your mind, right? It can go in so many different directions, right? So I remember with kids in some workshops remember when we could do workshops live with people around you, and kind of also remember fidget spinners when they were like the fury of fidget spinners. Everywhere was fidget spinners. We were working on 3D modeling a fidget spinner, and somebody was saying, okay, can I add a light that gets brighter when it goes faster? Okay, how would you do that? Well, I need something to measure the speed. How would you do that? And somebody thought, oh, maybe a magnet that we can measure the time it takes to go from point A to point B. Great. And then somebody said, can we find a way to make continuous kind of movements? Well, that may be a little far-fetched, but you get those questions. And when you get those questions, I think we're doing the right job, which is sparking that interest, no pun intended. So yeah, that's kind of what we want to do, is just opening those doors, right? So, and there's much more that you can do besides just making a 3D model and printing, which is great, by the way. But when you start putting all those things together, right? And again, you can add a servo, you can add motion, you can add different behaviors with our kind of electronic simulator, which also moved from only Arduino to Arduino and microbits, and then simulation of many different circuits. Our 3D modeling side that's also getting better. We also get something there that makes sense, and then also the coding, right? Coding both for behaviors on Arduinos and microbits, but also on 3D modeling, right? Because this thing here, this kind of base, looks extremely complex, but once you understand how to build it and you build it with variables, all of a sudden a small set of instructions can create extremely different parts, right? And that is again another moment in which you can realize, oh, there's so much we can do, right? And if you move into a life of mechanical design and mechanical engineering, that's parametric design at the end of the day, right? Which is sort of where you want to go in those scenarios. So being able to have that progression, right, from the very familiar to challenging more and more into more sophisticated tools is really important for us. Another important for us is have also not only those workers at the center, but also what is relevant for schools, right, for a teacher, right? So, and we all love 3, and we all love the same letters starting from. So it has to be relevant, right? So what we show in Tinkercad has to be important for the different standards, so for kind of the mindset at the moment, right? And that's the reason why we got questions on VR and AR, and we added some part of that, or electronics or programming. What's the next? Bioengineering, maybe, or whatever goes next, right? So also it has to be reliable, right? Every teacher wants to make sure that when they open Tinkercad with a full classroom, one day Tinkercad actually opens and it works well, right? So that's all on us. And again, 38 million people, 4 million monthly actives, 500,000 a day. That's a lot of infrastructure that we need to keep always looking at. And sometimes a big part of the year and a big part of the resources is just on making sure that the lights are on, which is not minor, but it's very important for you guys. And of course, then the other one is really easy. I didn't find something started with an R and easy, so I cheated. But it has to be really easy, right? So the learning curve has to be simple. And we start everything from something very familiar. When I put a box on Tinkercad, I see these little points there. They are the same that you would get when you are using Google Slides or PowerPoint and you put a shape, right? So you know exactly what each of these do because you've seen it before. I mean, you don't have the 3D side, but that's just one extra step on top of what you know. And then as we get into more complex things like a shape generator or stuff like that, that has full coding inside, you still interact like this. You don't do this. You consume this thing, but you use it in the same way as you use a simple box. So the complexity is all encapsulated. And I don't know how many of the people here in the audience have any sort of modeling background, but I do. I've been on this for more years than I can remember now, and I know that these three things are: this is an extrusion, this is a sweep, a loft, and this is a revolve, and they all started with the same with the same profile, right? The thing is that this is impossible. This is an impossible concept for somebody just starting, right? To understand that these three extremely different shapes started by the same 2D object, right? The abstraction from going to 2D to 3D is very, very complex to handle. And even I was teaching university kids, and it was even hard for them still, right? So on Tinkercad, we chose to, again, start with familiar things. And what is familiar for a Tinkercad kid, right? Every single first grade classroom in the United States probably has a big bin with all these shapes, right? Well, let's make the digital version of this. Let's work by aggregation, right? Let's put things together. What is the thing that they do before Tinkercad? They play with bricks. I'm not saying brands here, right? They play maybe Minecraft. They play stuff like that, right? So if I tell somebody, how would you build something like this, which we know is a chair and we kind of know how we'll build it, somebody with some training would say, maybe this is 4 legs and a seat, or somebody would say, well, maybe also I also want to have a joint there, so it's actually 6 parts. And I can bet my guitars that a lot of kids there will say, oh no, this is how I build it, right? And no answer is wrong, by the way, right? But there's a progression in the answer, and there's a high chance that the younger you get, you're going to get more of these, and little by little they'll start understanding that, well, all this here can be one single object and stuff like that. But we need to acknowledge that we need to catch the kids in the place where they are, right? And the place where they are is aggregation, especially if you're thinking about the younger audiences. I mean, it can be very aspirational to think that they can work on sketching and 3D modeling based on sketching. It is a level of abstraction that's not there. So creating the idea of product design, that mindset is very important for us. So from the very basic, like just putting together these like platonic solids, right? Like a cube, like a cylinder, like a sphere. And then realizing that each of those things, when put together in certain ways, create objects that you might want to reuse, right? So that's why we created the part library. So you can reuse things you've already done. If you go into any mechanical design job or architectural job later, we all have catalogs and parts, right? We all build and design based on things that already are there, that we've made or somebody else made, right? So this is not that difficult to understand, but it's good for us to start getting that narrative into their lives. Because eventually you're going to get into something like MasterCard or the different catalogs out there, and you would like to use those things in Tinkercad, right? So, my point here is that this progression goes from aggregating basic shapes to being able to reuse more complex shapes to actually kind of getting closer to what real life is later when you design, which also leads us to this is our audience, right? From building, from using Scribble as a way of sort of not sketching like mechanical sketching, but just like drawing to get a 3D objects, or using code blocks to make t-shirts, or laser cutting, 3D printing, using breadboards and Arduinos, microbits, right? I mean, all of this is the universe of any kid today, and you know it well. I mean, this is the reason why you're here, probably. And the good thing is that all that kind of moves, can keep moving forward, and maybe those same people will end up being the new engineers, the new designers. And this is also part of what we are doing very intentionally, which is understand the progression from the very first things you can do in Tinkercad into things you might be able to do later, right? So, and I think that almost everybody starts with a name tag. And that's a perfect example of something you can do. It's easy, right? So a name tag is probably a box with a cylinder, with a hole and a name, right? It's 3-4 objects, but 4 objects that can be easily printed because there's not much to really fail at on a decent printer on a name tag. It's flat, so it prints fast. It has somebody's name, so it's highly personal. It's wearable, so people can brag about it outside. I mean, you can take it to their homes, right? It's a perfect first example. But how do we transcend from that into something like I don't know, something with a NeoPixel, or eventually moving all the way into maybe designing a full PCB board with an enclosure and some great mechanical design in the future, right? So that's sort of what we are also doing. And if you've seen, for example, what we do on Tinkercad when you can send to Fusion, which is something that we only open up for 13 and over, right? But I think it's important to show is you can start from this 3D model that I showed before, right, in Tinkercad, in one of the slides, but then you can make better detailing on Fusion 360, or you can create better images by rendering, or you can do a full animation of how it's built, or you can have a simulation of how it's 3D printed, understand all the infills, or you can make in this case is stress simulation to understand exactly where's the force. Because here I just build an enclosure like a little control for a microbit, right? And use simulation for that, or just get good documentation, right? So those are steps that can come later and lead that into a great life of designing. At the end of the day, and this is the last one, we just want to make design part of everybody's lives, right? So, and by saying design, I'm not thinking about just the discipline. Product design is just solving problems in a creative way, and that might end up with a physical artifact that solves a problem, right? And solving problems is, to me, the most important thing. Then you can become a lawyer, a YouTuber, a football player, a designer, an architect, whatever. But at the end of the day, solving problems is going to be something you have to do every single day anyway, right? So I would love to think that we are part of that. I love to think that this is part of what we do, and also create an emotional connection, right? So great. I think that the difference between a good product and a great product is the emotional connection you can create with what people do, and encourage lifelong learning, right? So again, today Tinkercad is this, tomorrow can be something else, tomorrow can be something, other product, whatever, I don't care, but things move fast. We cannot foresee what's going to happen in 10, 20 years from now. I mean, easily, or even 5. And what we need is people that are curious enough to keep wanting to keep learning all the time, right? So I think that as teachers, as people interested in kind of the formative years of any kid, if we can just get people that are passionate and curious about what they do, I'll just put a check mark there and say, good job, pat our backs and say, great, we did it. And with that, I'm going to send back to Tim unless there are questions. I'm not keeping up with the questions here, because if not, I just get distracted immediately. So are there any questions that I need to answer before moving to the next level, to the next thing?
I think we do have a couple of new questions coming in through the chat as well as the Q&A.
Okay.
But they're not all product related. So maybe, Tim, would you be able to tackle the first one on the Q&A that's still open?
Yeah. So let's we had a question in the Q&A, and the question was, are your resources accessible to students with special needs? And I'd like to address that from the physical side of Sparklab, since that's my where my world mostly exists. In Sparklab, there are we take great care in trying to create activities that have universal design aspects to it, things that are intuitive to use, regardless of physical or mental abilities. So color cues, we use a lot of color cues. We use a lot of texture cues on different activities and different materials. We also have social narratives in the space for students who learn a little differently. So we have those available if you come in, if you happen to visit Sparklab once we reopen and you want to bring students or somebody who needs that type of learning process, you can just ask one of our facilitators if they have a social narrative available, which will guide somebody through the space. Everything from the objects in the space to the work that's being done in our open workshop that you can see, or the visible workshop, to the activities themselves and how the space actually operates. So from a physical aspect of Sparklab, we do have those types of resources available. And from a digital aspect, I'll let the Tinkercad and Autodesk team answer that, and I'll hand it off to whoever wants to take that one.
I can hop in here, Tim, because you brought up UDL, which is one of my favorite things as a teacher, because one of my certifications is in special education when I was teaching middle school students. And when you think about like the principles of UDL, I just think that Tinkercad is just an awesome medium or a vehicle for engagement, for example. So within Tinkercad, students can collaborate on projects with each other as well, so they can engage with each other. It's a great way of having like group projects with students, as Guillermo had talked about. It's also a great way to make learning relevant for students. So for example, one of the lesson plans that Jenny is going to be talking about that I helped on was redesigning a public space to make it more inclusive. So thinking about how you can engage students and evaluating spaces in their community and trying to make those spaces more relevant to them. In terms of representation, our awesome collaboration with the Smithsonian. We actually have Smithsonian objects digitally within Tinkercad. So that's a really great way to actually another way of sharing knowledge with students. And then also just, thinking about expression, students are able to, I think of Tinkercad not just as like a 3D modeling tool, but it's also a creativity tool. And I think it's also a really great communication tool for students. So just thinking about ways, other ways that students can represent their knowledge to others, either through the digital model, or maybe it's like an explanation of their digital model. So they do a screen recording of like a tour of a building that they designed in Tinkercad, and they can narrate over it rather than, doing a written essay. So I guess I'm biased, but I think that, the possibilities are endless with Tinkercad in terms of making learning accessible for students.
Absolutely. And I would say just more anecdotally from some interviews with teachers who have been using Tinkercad in the classroom for both general education and special education, what we've discovered is it's a fantastic use of differentiated instruction and small group instruction. So, in some scenarios, we find that learners are able to just pick up Tinkercad and, enjoy a really open-ended experience. In other ways, teachers are able to scaffold the opportunity so that it meets students where they are in terms of what they'd like to create and what they'd like to do. And then lastly, something that I really liked was this acronym from the National Center for Accessible Education Materials called POUR. So content that is perceivable, operable, understandable, and robust. So perceivable means that learners can see and hear the content. Currently, Tinkercad doesn't have audio, but we do have different ways to display the content. So in graphics as well as text for pictures. There's different modalities of engaging. So Jenny can talk about this maybe a little bit after, but that's certainly one thing that we want to make sure Tinkercad is able to do for all learners. Operable being that learners can interact with content in a variety of different tools, so using the mouse, but also there are keyboard shortcuts. What does that mean? It means a lot of times we're providing sufficient time for those interaction and responses, so teachers are often building that into their lesson plans with Tinkercad. The third one is being understandable, so that learners can understand and enjoy a predictable experience. With Tinkercad, what we find the beauty is there's a couple of very basic moves, and after that, it's about just combining, remixing, iterating to create sometimes really powerful and detailed designs. And so it comes from a very, very basic body of simple knowledge for how to use the tool, and you can build on that over time. And then the content needs to be robust, so it works well with both current and future technologies. And so that's something that I know Guillermo and the product team are constantly working to create. and is still in the works, as well as the team is developing more ways to reach more learners with a progressive web app, among other things in the pipeline.
Yeah, and I'd like to add just a couple things to what my colleagues have described along the lines of accessibility. Our learning content is designed to be self-paced and uses a wide variety of modalities like reading, listening, visuals, using brief videos. So for example, our lesson plan library does have an embedded video player in it. And of course, by its very nature, Tinkercad is open to creatively solving problems. And so there's no right or wrong way to do anything, and you'll never get corrected in such a way that makes you abandon, the software. And we're always looking for ways to improve accessibility as well. And we want our learning content to appeal to a wider variety of learners and interests. So thank you for that question. That's a really important one. And we're always looking for ways to make it, our product and our learning materials more accessible.
Thank you so much for that question. I don't see any other questions in the question and answer area. I know some folks have been answering a few questions in the chat. I think Emma's been answering some questions about exhibition or objects in the museum collection, if I saw that correctly. But I just want to thank you guys for those. And Daria, do you think this would be a good time for us to follow along, take that little break, and then maybe allow folks to sign up for Tinkercad if they don't already have access to it?
I think that would be great. So we'll go ahead and take a 5-minute break before the next section. The next section will focus on how educators can incorporate Tinkercad, Instructables, and those Smithsonian Sparklab materials into their education. And we'll give you a quick walkthrough. Kellyanne will be here to provide a quick activity demo featuring a Smithsonian shape. So please stay tuned. In the meantime, if you don't already have a Tinkercad account, please go to www.tinkercad.com. Please register as an educator, and you'll be able to follow along and see all of the resources that we're going to show in this next section.
That's great. So feel free to keep putting your questions and answers into the question and answer box. Feel free to be putting things into the chat. We will return in 5 or 10 minutes. How long of a break should we take, Daria?
What if we returned at 1? Sorry, I'm trying to convert into East Coast time. So
that's right. It's a couple minutes till 5 here.
Perfect. What about 5:05?
So all right. So we'll return at 5:05, and feel free, audience, to take a bit of a break. Sign up for that Tinkercad account if you haven't already done so, and we'll come back in just about 5 or 6 minutes and continue on. We'll answer some questions. We'll also talk about the lesson plans that are available on Tinkercad and how that really applies to something that's very useful in the classroom. So please don't miss out on that. And we'll see you in just a few minutes.
All right, well, our next section is called Getting Started with Invention Activities in the Classroom. So Jenny, if you don't mind, please take it away with Tim.
Sure thing. I'm going to go ahead and start sharing here. Okay. Actually, let me. There. How's that? Is that viewable to everyone? Okay, great. I would like to give you an overview of a feature that we've added in the last year, and it's the lesson plan library. And what you're seeing here is kind of a collection of different starting points that you can visit on Tinkercad as a teacher or a student to get started with the basics. So we have direct starters, which are concepts like align, placing, moving objects. We have Tinkercad basic skills, which are also called lessons. And so these are building some basic things using basic skills in Tinkercad. And we also have Tinkercad projects, which tend to go into a little bit more depth from beginning to end, building something using the skills that you've started or that you've been introduced to in Tinkercad. And then in the last year, we've added the lesson plan library. And the point of the lesson plan library is to give teachers a place to go where they can guide students along to learn something and also build something that aligns with standards and basic concepts and skills. And I'm going to show you a couple of these because it's always easier to see this in action. I'll talk to you a little bit about the background here. So in doing some research and conversations with teachers, surveys and such, we learned that teachers need versatile learning materials from Tinkercad that meet them where they are and help them teach foundational STEAM and career and technical education concepts and skills to their students. They need materials that complement their existing curriculum, that are modular, that are easy to use and adaptable for their custom purposes. And they also want to help guide students to build that foundation of 3D digital literacy and design skills that we talked about earlier. And just a brief overview of what the lesson plans were designed to do is to give teachers engaging projects to guide students through building these skills using Tinkercad. And so our lesson plans include prompts for student inquiry, like brainstorming and taking notes that students can do individually or in small groups. It focuses on creative problem solving and using processes around design thinking and engineering design. It combines disciplines like math and engineering and science, sometimes within the same lesson plan. It gives students the opportunity to build 3D design skills without necessarily having access to a 3D printer. I mean, there are lesson plans that include a printing component, but it's not a requirement for them. They're also, as I said earlier, anchored by academic standards like ISTE, next generation science standards, and some Common Core standards. And as I said earlier, they're modular and they're designed to be adaptable for a wide variety of educational needs. And so it was really important to us to design this gallery in a way that made them teacher friendly with features like, well, first of all, they're free, of course. They're always publicly viewable, so no sign-in is required unless you're going in to modify a Tinkercad file. And so what you're looking at here is a snapshot of the landing page for the lesson plan library. And you can see that you've got visual cards, and it gives you a glimpse of what's included, like the appropriate grade range, the duration, the subjects, and the skills that are addressed. The lesson plans are easy to use for either in-class or remote learning, which was very important, especially this last year of hybrid learning. There is a teacher view and a student view depending on how you're logged in. So if you're logged in as an educator, you can see certain notes that apply to, obviously your interests as an educator and guiding students through. And it also allows you to, as a teacher, share the lesson plan directly with students or send them to Google Classroom. And you can also, these lesson plans incorporate, like I was talking about earlier when we had the accessibility question, we have brief videos, we have slideshows embedded, we have fillable worksheets that can be downloaded and customized per student. And we also have a rubric for every lesson plan that teachers can use and customize per student. And then something that we've added recently is an option to download the lesson plan in a printable PDF format. So if you want to look at it all at a glance and evaluate it for your needs, you can have it there as a way to download it. And then you can explore the links and such within that printable version of the lesson plan as well. So I'd like to talk a little bit about our instructional design process here. As I said, we started the project by talking to teachers and finding more out about what their needs were. And so our lesson plans are designed most often in collaboration with educators and partner organizations like Sparklab, who, we've talked a little bit about the projects that we are featuring on our lesson plan library from Sparklab. But in general, the author will pitch an idea to us, like a lesson plan idea that's relevant and engaging for their audience. And then we have a storyboard format here. I just included a screenshot to show you at a glance what that looks like. The author works on some relevant academic standards for the proposed lesson plan and then creates all the assets. And we might go back and forth a couple times to refine it before posting it live on our site. So here is a screenshot of one of the newest ones that we've launched. And this is Reinvent the Shopping Cart, which we've referred to a couple times during our presentation today. In this lesson plan, you can explore the different links. As I said, it's modular. They're broken up by time segments. So if you only have 45 minutes, you can easily plan against that. The printable version of the lesson plan is a link provided here. And again, we're working on adding that to all of our lesson plans. It's a new feature that we have recently added. And here's an example of a printable worksheet that you can download and then customize. The purple boxes represent where content can be typed in and saved. So this is an example of something that you might, as a teacher, share with a student to help them go through the try it portion of this particular lesson plan. And then here's just another landing page for the Invent a device that can move through a pipe lesson plan that Sparklab also created with us. And here is an example of a rubric that a teacher can download and then customize per student. And again, the purple boxes represent where you can type information and then save it by student name and record score. And so, as I mentioned, our lesson plans align with academic standards, and I wanted to just show you here a couple of the ones that apply to the Invent a Device lesson plan. So we're talking about ISTE and ISTE standards here, and then also Common Core math standards for grades 5 and 6. Tim, I want to give you a chance to jump in here if you had anything to add about how we came about choosing these lesson plans and incorporating them into our library.
So that's great. So it's the lesson plans. This actually did come along a little bit after we began our digital pivot, where we started posting on Instructables and then creating designs in Tinkercad. We then began some conversations with Autodesk around the lesson plan format. And one of the things that we really liked about this is Sparklab itself is even though we're steeped in educational pedagogy on the back end, it's not necessarily front and center in the exhibit space. So one of the things that we really were hoping to be able to do is reach out in a way where we can actually get school standards in there and provide resources that teachers could use that fit with the curriculum pieces that they're teaching and fit with the different standards that they're trying to cover. And the lesson plans were a great way for us to do that. The Instructables were nice in that a lot of the same content is there, but this was a much more structured way for us to lay that out and make it more available and an easier to use tool for teachers in the classroom to just grab a hold of, know how long something's going to take, know what kind of standards they're reaching out to, and know what they can expect from this particular lesson plan. Again, as we developed this with Tinkercad and as we worked with it, we use our base model from our Instructables activities, but we do make a few adjustments, a few tweaks so that it does fit a little bit better in the classroom. And one of the things that we've talked about with Jenny and the team at Autodesk is how we really want the outcome to be completely open-ended. We want the outcome to be different from student to student, because we are looking at it as the invention process. And I know a number of the lesson plans are the same way, where those outcomes are completely open-ended, and except for our focus is, I think the only real difference is our focus is here are the steps of the invention process, and this is what it's like to walk through them. The one challenge with this, but which is really nice though, that we can do in the lesson plans, is students can revisit steps a little bit easier than they might be able to on Instructables. And Invention, for anybody who's taught Invention who's using Invention curriculum, as you guys may know, Invention is not necessarily linear. We laid out those 7 steps of the process, but that's not always how that works. A lot of the time you'll revisit a step earlier on. You'll go back and rethink what you've done. You'll go back and do more research, like the Explore It section. You'll go back and think about things in a different way and then jump back into it. And with the lesson plans, that makes it very easy for a teacher or a classroom to be able to do that back and forth, which we really appreciate and we really like, because it does convey that invention process in a way that works well and also fits well in a classroom.
That's right. And so they are open-ended by design, and we are inspired by project-based learning in the lesson plan gallery, and such that, the student might have a question they ask at the beginning, or they've got some creative parameters to work with, but there's no right and wrong answer, and there's no way that you can really fail in these. We give them some guidelines, some brief directions, and let them go and make what they'd like. And again, it's meant to be for the teacher to have open-ended materials to work with that are adaptable for their purposes. And so thank you, Tim, for adding that context. What we're looking at here is just some screenshots I grabbed where people are discussing our lesson plans online. And so, we're really excited when we see teachers creating projects and sharing them online or sending them to us by email or whatever the situation is, to find out how people are using them and ways that they're making their classroom instruction more dynamic. And so, we're doing a lot of things to try and improve our lesson plan gallery. First of all, most of our lesson plans right now are within the 3D design space. And of course, we have Codeblocks and we have circuits workspaces as well. And in a couple of weeks, we'll be adding our first circuits lesson plan. And we do have a couple lesson plans right now that use Codeblocks as part of the plan, but we will be adding more of that this summer. And we will also be expanding the number of subjects and grade levels that we're addressing. And another thing that we're starting to do is to tie the launch of our lesson plans to different STEAM dates and themes. So for example, National Robotics Week, we tied one of our lesson plan launches to that. We have World Industrial Design Day, Manufacturing Day, World Creativity and Innovation Week. There's a lot of themes that teachers care about that they often align their own instruction with. And so we wanted to help teachers find activities and projects to do in alignment with those STEAM themes.
And I'd like to throw in a shameless plug here in that we are, as Sparklab, we're looking at these different days and stuff, and some of our activities that we're trying to design that will go into the lesson plans, we're trying to find stuff that does fit in there, because we do want to add to the lesson plan. So as you go through and try out some of the lesson plans, please do look for our designs, look for our pieces that also tie into some of these days, and even ones that maybe haven't been promoted to tie into them. Think about how you might be able to use them to promote, like World Industrial Design Day or whichever day you're really focusing on in your classroom.
Yeah, so thank you very much. That's kind of our overview of the lesson plan gallery.
Perfect. Well, Kellyanne, would you mind bringing us straight to our last segment for this presentation, which is a demonstration of how to get started with invention activities in the classroom using Tinkercad as a platform?
I would be delighted to. Thank you, Daria. All righty, can you see my screen? Yes, great. All right, so this is just meant to help you. Hopefully you've been inspired by hearing from Tim and from the Tinkercad team and the Instructables team about all the possibilities of what you can do with students to empower student voice, and even how you could introduce Tinkercad to your colleagues as well. So this is just a little demonstration to help you think about even making a thing in Tinkercad, and also sharing what you learned with students, how to get started teaching Tinkercad with students, or if you're going to lead this as a professional development activity for your colleagues. So when I do any type of learning with students, be it young adults or children, I'd like to tie it into like a fun design challenge. So for this activity, I just, thought about, I've been doing a lot of baking at home. I think a lot of people have, and watching fun baking TV shows as well. So how could we maybe use Tinkercad to do a fun activity where you could do some digital baking? So I think it's also fun to, as Jenny had talked about with the lesson plans, to tie that activity to some sort of occasion or an event or something that's relevant to students or to teachers' lives. So recently, Tinkercad celebrated its 10th birthday. So this kind of tied into this cake design activity as well. One of the reasons I'm sharing this with you too, not just to celebrate Tinkercad's 10th birthday, is also to just share with you as a resource that within the gallery in Tinkercad, which is a great place to start, you can actually find a whole bunch of really cool cake designs, because for a 10th birthday, if you do hashtag Tinkercad 10, I'm going to show you this in a second. In the gallery, you can find all types of cakes and other type of festive regalia that the Tinkercad community designed to celebrate Tinkercad's birthday. So it's a fun place to start. And my video is, oops, okay. All right, so let me switch to, my video is denied. All right, let me stop sharing my screen for a moment. And then I'm gonna go into my version of this. Sorry, Daria. It was with
My
the
apologies.
different copy. Yes, technical difficulties. I'm going to go into my version, and I'll just have to share with you verbally what the challenge is. All right, back in action. Here we go. All right, hopefully the videos work here. Let's view, present. All right. Okay, and the videos are working. So you should test that before you are sharing this with colleagues and students. So when you go into the Tinkercad Gallery, you can see there's the starters that Matthew talked about. So these are, one fun place to start with students, but another fun place to start with students is in the gallery. So if you go into the Tinkercad Gallery and you put in hashtag Tinkercad 10, you can find all these fun cakes. And one of the things that I find with students is sometimes they are intimidated by the blank canvas. So if you go into the Tinkercad Gallery, you can let them know that a lot of designers, what they're doing is they're copying and remixing other designs and even like reverse engineering others' designs in order to learn. So it's a great place to start. So if I were to frame this to my fellow educators as a design challenge I would do with them, I might say to them, imagine it's the end of the semester and you are hosting a public showcase of student work. Design a cake for your students to celebrate their learning. So that's one way to get your colleagues hands-on in this design challenge. Or similarly, I actually just did this recently with students in the first robotics program. So imagine, you have a group of students and you're saying, imagine you're hosting a party for your robotics team to celebrate the end of the season. This was a particularly challenging season for students on robotics teams, for example, because they've been, experiencing distance learning. So design a cake or a cake topper that recognizes the team's accomplishments and even maybe encourages your teammates to keep going. And this is actually an example. I did this activity last weekend with students from First Robotics in Paraguay and in Paraguay and in New Hampshire. And this was kind of what they came up with in celebrating each other. And there was a partner that helped 3D print them as well. So you can frame this challenge with students or with your colleagues as a design thinking activity in addition to a Tinkercad activity. I'm not going to go super deep into design thinking, but it's a similar process to what Tim was talking about with the Invention process. So the design thinking process, this is just 5 phases that we're showing here. We'll share this slideshow with you later as well. This is a fun video that you could share with students to talk to them about how this could be a design thinking activity. But I'm going to focus primarily on Tinkercad. So for the Tinkercad aspect of this activity, you would send your students to tinkercad.com. Tinkercad, it's free, it's easy to use. And like I said before, It's not just a 3D design tool, it's a creativity tool, it's a communication tool for students. It works quite well on Chromebooks, on iPads, as Guillermo had spoken about earlier. The fun kind of bonus of using Tinkercad on an iPad is that students are able to unleash their designs into the real world using augmented reality. So there are 3 environments within Tinkercad. There's the 3D editor, which is where we're going to primarily focus on today. There's also the circuits or electronics editor. And then lastly, there is the Codeblocks editor. And I do have a little demonstration of Codeblocks as part of this activity. When you're using the 3D editor in Tinkercad, you're just dragging and dropping shapes onto the work plane, combining those shapes to make new, more interesting shapes, subtracting from those shapes to make holes and add additional complexity. And again, as Jenny had noted, you can think about teaching Tinkercad as also a way to teach about making and manufacturing and fabricating. But you could also just, if you don't have access to a 3D printer, there are other ways that you can, that students can find value in their digital designs. We'll talk about that a little bit too. So Tinkercad, you can start small. You can design a car in Tinkercad. Again, if you're going to 3D print it, you might also think about other materials that you could add to it, like a balloon, for example, to make it move. You can think big and architecturally in Tinkercad. You can teach students how to design computationally. So this is just another sneak peek of that Codeblocks environment. So this is the design of a bridge computationally, a very famous bridge, I think, for my West Coast friends. And last but not least, one of the things that I really love about Tinkercad is it really helps you help students see themselves in STEM. And also it's a great way to add arts into STEM. So to put the A in STEAM. And needless to say, these are all also great ways to introduce exciting career paths to students. So when I'm demonstrating Tinkercad to both students and to teachers, I think about it, as a teacher as kind of, it's almost like a think aloud, like if you're teaching a piece of literature, for example, and kind of highlighting some of the strategies that the writer is using or some of the strategies that you might be using as a reader. It's kind of similar. So I'm going to start with just the cake is also just a great way of showing some of those basic moves in Tinkercad. So this is how you would align in Tinkercad, which is a really fun tool, and also how you can take a piece out. So as you can see, I'm in my dashboard right now, or in my work plane in Tinkercad. You just saw the dashboard, and I'm just dragging and dropping shapes onto the work plane. So I chose a cylinder. I'm manipulating it, so making it bigger, but holding the shift key as I'm making it bigger. And then I let go of the shift key to squish it down smaller. So I'll show that again. You can easily change the color of the shape. And then some of the shapes, like the cylinder shape, also have these interesting parameters that come out that allow you to kind of play around with the number of sides, or to add a bevel, or to play around with the segments. And I did this because I wanted to make it look round kind of at the edges like a cake. So not all those shapes have those, but the cylinder does. So now I'm duplicating the shape. So I did Command D to duplicate it because I'm on a Mac. If you're on a PC, it would be Control D. A lot of the same shortcut keys that you might use, like if you're using Google Slides or using, editing a picture, for example, a lot of those same commands work in Tinkercad too, including Command Z if you make a mistake. So next, what you see me doing is I selected both these shapes, and then I'm using that Align tool at the top to center my shapes. You can select your shapes by drawing a box around them like you saw me doing here, or you can click on that. I'm duplicating that shape now. So I did Command D again. I'm lifting it up the Z axis using that black arrow, and then I'm making it smaller again. And again, I'm maintaining the proportions of that shape by holding down the shift key. If I let it go, it might squish it. So next I'm using that Align tool again to center my shapes. And you'll see me using my view cube a lot. Camera controls are super important when you're using Tinkercad. So what you saw me doing there is I selected all the shapes and then I grouped them together. And then you saw me actually at the bottom of my screen, I changed the snap grid that to 5 millimeters so that I could move my shape more quickly. So next I'm going to take a slice out of the cake. And I am going to, so I dragged out that roof shape. I stretched it out with that handle at the top. Rotating, I would say, is a move that might be the trickiest to master in Tinkercad. If you use the outer dial, you can make more kind of precise movements. If you stay within kind of inside that dial, it moves a little bit more quickly. But you can also type in. So I could type in like 90 degrees or 180 degrees, or oftentimes your friends in Tinkercad. So you can type in as well. So I dropped it down the work plane using that black arrow down the Z axis, which makes Tinkercad really fun. And again, you see me kind of just looking around. It's really important to inspect things, particularly if you plan to 3D print them later on. You want to make sure that all your pieces are connected. So next, I stretched this out really big, and then I turned the roof into a hole. And why I did that is because I want to subtract this slice from the cake. So I'm just using my arrow keys actually to move the slice into the cake. And once it's there, it's looking good. And I'm inspecting it. I'm drawing a box around these shapes. And then I'm grouping them together so that they are one part. And then you can see that there we have it, a slice out of the cake. So I'm going to show that kind of the same things that I just showed a couple of times. And that redundancy is oftentimes good when you're teaching, particularly adults, but also kids too. So I might also, when I'm teaching this to my colleagues or to students, I might ask them a question afterwards. So for example, after I made this fun cake design, I thought like, how could I make the inside of the cake chocolate? So this might be a question that you could ask students to kind of extend their thinking. The answer to this question is not as simple as one might think. Anybody want to take a stab at the answer to this question? How could you make the inside of the cake chocolate? Maybe someone on the Tinkercad team. Is this a stumper? I will give you a hint. So I thought that this might be easier, and then I realized that I had to keep duplicating the same shape over and over again. So first I had to hollow out the tiered cake shape. And then once I hollowed it out, then I had to actually make another version of the cake chocolate to put it inside. So this is a fun kind of brain teaser question that you could ask students just to kind of get them thinking. So another thing that students in particular love to do is to personalize their designs. So one way that you could do that in Tinkercad is by importing an SVG into your design. So the way that I added that Tinkercad logo to the cake is I had an image of the Tinkercad logo. I had it, so you need, if you're going to import SVG, which is a scaled vector graphic, you need to have a black and a white image. So it can only be a 2-color, really kind of one color image that I had a PNG file, which is, you could also do a JPEG file as well, but it's usually going to be the PNG with a transparent background. And I just converted this image using an free online, I think it was like PNG to SVG converter. We are not endorsing any online converters today, to turn it into an SVG file. So from here, once I had that SVG file, I'm going to add it to this cake. So I'm going to click on Tinker This. I am going to, I think I switched to orthographic view so that I could get kind of a more 2D view of the cake. I chose a file. So I import and chose a file. I chose that Tinkercad logo. This happens to go in perfectly fine. Sometimes when you're importing an SVG into Tinkercad, it's too big. My trick is I just scale it from 100 down to 10 to make it smaller so that it fits in. So if it yells at you that your file is too big, just try changing 100 to 10 and see if that works. So now I'm squishing down the Tinkercad logo. I'm going to switch back to perspective view to make it more 3D. I'm lifting the logo up off the work plane. I am zooming out. And then I'm just aligning it. So you see me using that align tool again. If you have a little bit of OCD tendencies, the align tool is your friend. You can make things very centered and perfect. So here then, and if I were to do this again, I'd probably use a work plane to put the logo on top of the cake. And you'll see me using the work plane later to do that. So there you go. So that's how you add a logo. And if you wanted it embossed on the cake, you do it that way. But I'm actually going to group this together. Actually, no, I was aligning it. I'm going to turn that logo into a hole. And now I'm going to create a debossed effect. So I'm kind of indenting. It's almost like it's stamped into the top of the cake. So you have options there too with the logo, or whatever image that you want to add to your cake. So the next step is to frost it. Before I move on to frost it, are there any questions? All right, I'm going to move on to frost it then. And this introduces another fun move in Tinkercad. So again, this is my dashboard. I'm creating a new design. I am dragging my cylinder out onto the work plane. I'm going to change the color of the cylinder. I am again holding down the shift key as I'm dragging that handle up to make it bigger because I want to maintain the proportions. And then I let go of shift to squish it down. I'm again playing with those fun parameters, the number of sides, and the segments, and the bevel. And then I have what looks to me like a nice cupcake shape. So again, this is now work plane. So if you want to make sure that your shapes are connecting to each other, this is particularly important if you're going to 3D print it, you would drag a work plane onto the surface of wherever it is you want to place it, and it goes directly there. There's also a shortcut key as well to put things directly on the work plane. That's on, I believe, the teach page of Tinkercad, all the shortcut keys. To get rid of the work plane, that orange one, you just drag another work plane down onto the blue work plane. And then I'm centering the shape. So I've got my torus shape frosting. It looks delicious. And I'm going to do Command D. So Command D is duplicate. But next, I'm going to move it slightly up the Z axis. I'm going to make it slightly smaller. And then I'm going to hit Command D, Command D, Command D over again. And if you're on a PC, again, it's Control D. And that is what's called smart duplicate. So if you're doing a smart duplicate, it creates this, so it doesn't just remember the shape. Tinkercad also remembers whatever movements that you did. So if you change the angle slightly, or if you make it slightly smaller, if you move it slightly, it's going to repeat that pattern over and over again. So you can see kind of the fun that students could do, like making spiral staircases, for example. So smart duplicate is a really fun and powerful tool in Tinkercad. So now I'm just adding a dollop of frosting at the top. You'll see in my example, actually, after I made this, I kind of then went back into it and changed the toruses. I adjusted the angle slightly to kind of make it look more natural, the way that the frosting is layered on there. So that's frosted. And then you might stop and ask students questions about, for example, one obvious way to bring your design into the physical world might be to bake it. Another way could be to 3D print it. But what if you didn't have access to a 3D printer, or if you weren't able to bake it right away and you wanted to actually prototype it first, maybe it was an intricate shape? This could be a question that you could ask both students and colleagues. And one way that you might, one example is this example from Bajika, which is a design studio in Boston, or in the Boston area in Massachusetts, that came up with this really cool way of fabricating a cupcake using Tinkercad out of cardboard. And as you can see here, what Nisha from Bajika did is she took used Smart Duplicate, and she basically used the work plane almost as kind of like a slicer, like the way that you might slice a design to 3D print it. So she duplicated it and then sunk it a little bit down the work plane, and then duplicated again and sunk it down a little bit further. and then ultimately turned that into an SVG. So when you make an SVG, if you export as an SVG in Tinkercad, it just captures what's on the ground plane, so on the work plane. So she's got these different size circles that she then was able to print out just on regular printer paper and then trace it onto cardboard to make this interesting cupcake. And I share this with you because it's also an interesting way to help students understand how a 3D printer works, even if you don't have access to a 3D printer. Because if you're sending your design as an STL to 3D print, you'd have to actually put it into a slicer a slicing program in order to make these horizontal wedges to 3D print. You could also start talking, start a conversation with your students about how does 3D printing food work, and thinking about 3D printing as a way to prevent waste, not just in foods, but in other industries, for example, the building industry. And 3D printing can make fun foods too. So next step is, maybe the students are designing cake, or maybe they're designing a cake topper. So this was actually my cake that I designed for Tinkercad's 10th birthday, which was really silly. All I did to make this, the primary feature that I used is the shapes collections within Tinkercad. Within Tinkercad, I believe you can find Peter the Penguin. You can also find this fun Velociraptor, but you can also find all these other kind of pre-made shapes, again, for students who might be kind of intimidated by that blank canvas. They can hop into the shape library and find Elvis or find different figures. There's also other playthings, and this is all in the shapes library within Tinkercad. I think scenes as well is another one. So there's like trees, structures, and scenery. So you don't have to start out with a blank canvas, in whether the students are making something small or something big that has trees. It's also nice to add little elements for scale. So now I'm in the printables collection, which shows all these awesome Smithsonian objects that were part of the Smithsonian's open source project of open sourcing their collection. So I grabbed the Umbria orchid, and you can see that you can take something from the Smithsonian collection and add it to your Tinkercad design. I didn't take the woolly mammoth or the triceratops skull because I didn't want to outshine the velociraptor there. But that's the orchid. And the other thing that's great about the Smithsonian collection within Tinkercad is all of these digital objects from the Smithsonian collection can be printed as well. So that's why they're called the printables collection. So next is decorate it. So this here is also features how you can use the scribble tool within Tinkercad. So I'm just clicking create a new design. I'm going to grab a box this time. Box has different parameters than the cylinder. So I'm just playing around with the size. I am changing the color. I am also changing the edges, the radius, to make it a little bit rounded. Kind of looks like a sheet cake. And you also, again, see me using the snap grid to just change the increments a little bit bigger so it moves faster when I use the arrows. And then I'm going back to 0.5. You can also change in your snap grid from meters to inches, or millimeters to inches. I like to work in millimeters. All right, so what you see me doing here is grabbing the scribble tool. And you'll see that once you grab the scribble tool, it brings you to this kind of 2D plane where you can draw in 2D. So what you see me doing here is kind of similar to like what you might see someone at a bakery doing. Like if you go to the supermarket and have someone put someone's name on a cake. So Guillermo talked earlier too about that kind of going from 2D to 3D, and that kind of being able to do the mental origami of figuring out how 2D translates into 3D. The Scribble tool is a great place to start. And also for younger students, it's really tactile and really kind of empowering and to be able to personalize your design in such a way. So I'm changing the color of the frosting. I am zooming out. I'm aligning the frosting to the top of the cake. And then from here, I was starting to think about like, I'm going to make it a little bit smaller because it's kind of spilling off the side of the cake. Lifting it up the Z-axis, using that black arrow, zooming in, making it a little smaller. Right, and then switching to multicolor. And the reason why I did that is so that when you group shapes together, unless you switch it to multicolor, it'll change to the same color as the your two shapes will become one color. So I switched to multicolor there. So next I was thinking about, again, like playing on that concept of going from 2D to 3D. And how could I start that? I started to think about like piping tips and how how interesting piping tips are when you're baking, that you can start with this kind of 2D shape that's at the end of the piping tip and then translate it into something that's more 3D. So I'm making this star here in Scribble. I'm going to click done. And then I am using that rotate tool. Again, 90 degrees is often Tinkercad. You can also type in 90 degrees as well. I used the dial. And again, I used the outer end of the dial to move in kind of slower increments. So now I'm holding down the shift key to squish it down. I'm lifting it up the Z axis to get it onto the work plane. And then I'm thinking like, what happens if I extrude this 2D shape into something even more 3D? It comes in a little bit extruded, but what happens? I'm getting fussy with the color. But what happens if I stretch this shape out? And there it's starting to look kind of like on the edge of a cake, like the icing that you might have as a border on the cake. So then I'm speeding up my my video here. And so next I am adding that to the side of the cake. And then once I have one shape, I'm then going to duplicate it and then add it to the other edges. So these, we can share the link to this slideshow with you, but these are all demonstrations that you can use and you can talk over to your students as well, or to your colleagues, in explaining how they can make their cake. So I'm going to skip through. So this is a fun conversation also to have with students or with your colleagues, is once they've seen how you can make a cake in Tinkercad, like what are some other foods that you could design in Tinkercad? Pasta has been something that I've been interested in reading about. Jenny actually told me about cascatelli, which is a new form of pasta that, when you think about like the pasta shape and the idea of form and function, it's a fun conversation to have. So that's a fun conversation. There's some more videos about how you can get super fancy using Tinkercad, using the Scribble tool. This is like super ultra fancy. There is, you can start talking about the connections between math and design and thinking about how when you are using solid shapes and holes and combining them and then recombining them again, how you could even start having a discussion about like Boolean operations, or what are some other ways that math and art or design intersect with one another. There's another demonstration of how you can use Codeblocks. So this is an example of how you could create a computational design on your cake. You can even start thinking about, if you were to make that computational design with your cake, how could you then, integrate robotics into your baking activity? So this is an example from the Autodesk Technology Center in Boston, which is co-located with America's Test Kitchen. So they had the question of, could a robot make a pancake? And you can see they're very excited here. They addressed that problem and solved it, but this was actually the 5th or 6th iteration of them trying to make that pancake. So our challenge to you, and what could you make, is to think about, imagine you are hosting a party for your colleagues and or fellow educators to celebrate the end of this challenging school year. Design a cake or a cake topper that encourages them to keep going. So we encourage you to take what you learned today and to engage in this challenge with us. So again, in this slideshow that we can share with you in the chat, and I'll make sure all the videos are publicly viewable as well. It shows you how you can actually walk through and even integrate the design thinking process into this cake making activity. Again, just to remind you about all the examples that are in the gallery. And also just make sure that you share with us. So I know that we're using #EdGamesExpo. So if you make a cake in response to our challenge, please make sure that you also tag us and let us know. And make sure you share. So that's the end of my formal presentation. Sorry for my technical glitch at the beginning, but I will make sure that the videos are all viewable as well.
Not at all. That was real-time problem solving and technical troubleshooting.
I tried my best, sorry. So any questions?
I have not seen any new questions come in. So nothing new there. I think we're pretty close to wrapping this up. So one of the things that I want to share is that, you know, as you can see, the Tinkercad platform, the Autodesk platforms, the Instructables platform, those were all extremely, you know, powerful platforms that we've only begun to utilize when it comes to converting our physical space into a digital space. So there are so many different tools that are available, and we just, you know, hope that the teachers who are taking part in this session can see those tools, and also see the tools that we're trying to provide through our Invention education outreach as well, and how these two platforms, the two ideas of Invention education and these platforms, have married up in order to create something that is, you know, that's very helpful and very useful, hopefully for you in your classrooms. With there being no more question, with there being any question or no questions in the question and answer, I think this would be a good time for us to put up the link page that we have. Matthew, do you have that there available?
Yeah, I'll share it. I'll share it right now and in the chat.
Okay, cool. So one of the things that we wanted to share also, Kellyanne has the link there for the slides. We also wanted to put up this this slide here and the links in the chat, so that if you are interested in any of these platforms, utilizing any of the platforms, utilizing the Sparklab Invention challenges, or finding us in Tinkercad or Instructables, as well as all the different options that Tinkercad has available for you to use in your classroom, you know, all the links are here. Go ahead and grab those and use those as you need. One of the things that this whole team is all about is, you know, really reaching that next generation and the current generation in education, and trying to find ways that are creative, that are fun, that are open-ended, and that really prepare students for the future. As Daria said in the very beginning, the jobs of the future, we don't know what those are yet. And a lot of the times in our Sparklab space, we talk about that as kids invent. We talk about how kids, you know, they're trying things and they're doing things, and they're going to have jobs that don't even exist yet, that are currently being invented right now, those jobs. So these types of tools will allow students to be able to be more flexible and more nimble, and think more inventively and more creatively as they go forward. So Daria, any parting thoughts?
No, I think you said it beautifully. If there's anything else I would add, I would just say, I think, Kellyanne, your presentation demo took us kind of full circle from how did we go from Sparklab's physical demonstrations pre-pandemic to transitioning to digital learning tools using Autodesk tools such as Tinkercad and Instructables, to how do we take this back into the classroom, and now that some schools are finally coming back to in-person learning, what does that look like to create this both over software tools, but then also bring it to life in classroom application. So to me, it's just truly the full circle of the creative and invention process. So thank you everyone for being here.
Yes, thank you. And I want to extend an invitation real quick. I want to extend an invitation for those who are taking part in this presentation. Once Sparklab, the museum is open now, but Sparklab is not. But once Sparklab reopens to the public, if you happen to be in the DC area and you're in Sparklab, ask for Tim or Emma or any of us, or ask for any of the Sparklab team. Please visit us and say, and let us know that you saw us at this conference, and feel free to ask any questions that you have at that time too. All right. Thank you so much, everybody. I think that's where I think we'll call it a session, and we'll give you guys 5 minutes of your time back. And thank you so much for taking part. Bye, everybody.
Everyone.
Thank you.